All right, where were you August 21st, 2017? I don't know if you guys know that date very well, but that was the date of the great American eclipse that went across our country. I hope that you guys got to see it and experience it, and when I get back, I'd like to talk to you guys, share your experiences. But today we're going to be talking about solar eclipses, okay? And how they work, why we only see them 2 times per year, give or take, etc. So here's our setup, and what moon phase is this for a solar eclipse to be possible? So you guys can think about that real quick. So the moon's here, here's the Earth, here's the sun. That's right, these are only possible in a new moon phase, okay? Now, every new moon, there is not a solar eclipse. That's why there's only 2 per year, okay? So if we take a look at this, even though we have a new moon once a month, so we have 12 opportunities, only about 2 of those opportunities can we get as a solar eclipse possible. Then we'll talk about why they don't happen where we're at. But if you take a look over here, I have this diagram, and this is called the ecliptic. And so here's the sun, here's the Earth, and really all of the other planets kind of orbit around the sun at the same plane, okay? Well, our moon does not follow that ecliptic. It's about 5 degrees off, and it rotates around us at that 5 degrees difference as we're going around the sun. So the only way to possibly have a solar eclipse is to where we're in new moon phase and the moon has crossed that ecliptic. Okay, so that's why it's very difficult. Also, why we may not necessarily see them everywhere is because our planet is predominantly covered in water, the ocean. And sometimes these will not happen over land, or it's just a small part that skims. So I hope that you got to see at least a partial eclipse. I did make the trek up, and I was in the path of totality, and I tried to get as best I could to the center of it. But you really missed out, guys. If at all possible, in your lifetime, try to make it to where you can see a total solar eclipse. It's unbelievable. Again, share my stories later. But if you were in Klamath Falls, we had a 94% partial eclipse, okay? And it was pretty cool from what I've heard from other people. Well, what's the difference between making it to the path of totality and seeing a 94% partial eclipse? Well, we need to talk about the sun a little bit. The sun's disks, which is its face, is about 1,000,000 times brighter than its corona. And the corona is kind of the things that stream off, the ions and things that stream off, and it looks kind of gray here. So because this is 1,000,000 times brighter, even if you only have about 6% of the sun still visible, a sliver of the sun visible, here's our equation. You take 100% totality minus a partial percentage of wherever you're at, and you multiply that by 10,000. And so for Klamath Falls, 100 minus 94 is 6 times 10,000. You guys experienced a 60,000 times brighter eclipse than what actually happened at totality. So it's pretty crazy to think about that. So what are the mechanics? How does it work? Well, when the moon gets in this perfect spot and it blocks the sun. Now, this is not to scale. All of my diagrams, I hope you've noticed, are not to scale. But if you take a look at this, it's amazing. Right now, the moon and the sun is 93 million miles away. The moon is 250,000 miles away, a quarter of the 1 million. This is 93 million. But the size difference, when the moon lines up perfectly, it will block the sun, and we can get a total solar eclipse. Now, how does this work? Well, the sun's rays, they go across and on the inside. So, for example, I don't know if you've ever done this, but maybe you should try it at home. If you've ever had lights behind you and you see your shadow, you see that there's a part of your shadow that's really, really dark, and there's a part of your shadow that's not as dark. All right, the same thing happens when the moon's shadow is cast on the earth. And so this really, really dark shadow is called the umbra. Okay, and this is where you would be able to see a total solar eclipse. It can span maybe 100 miles wide. Okay, the one that went through Oregon at that point in 2017 was about 60 miles wide, the path of totality. But this path of the lighter shadow is called the penumbra. This is where you would see a partial eclipse, and that can stretch hundreds of miles on either side. So this just going to be a little sliver on the earth that would be able to see a total solar eclipse. All right. So what happens during a solar eclipse? All right. So we have the moon shifting in front of the sun and blocking out its light. And we have 4 stages, 4 parts to it. And the first contact, is where the moon just starts to make the edge of the sun. This can last from contact 1 to contact 2. It can last hours. I think 2017 it lasts about an hour and a half, where the moon slowly moves in front of the sun. All right. Now, the second contact is when this sun's light just starts, this edge and this edge have now started to block it out, and we might see a little bright brilliance of light. From second contact to third, this is where totality happens. This can last depending on where you're at in that sliver of earth. Let's say this is the path that it makes across. If I am just out here on this edge of totality might only last seconds. But if I can get into the middle, get into this exact middle part of totality, it can last up minutes. The one in 2017 lasted for about 5 minutes where I was at. It can last up to 7.5 minutes. So third contact is when, as the moon is moving this direction, now we just start to see the edge, and this is when totality ends. And I'll try to put some pictures on here of this diamond ring effect that happens on these edges. It's pretty amazing. And then it continues to reverse and continues to move. The moon moves across, and this is the reverse of contact 1, and it slowly goes away. So conditions have to be just right with the path where the moon is at in its orbit around us and where our orbit is around the sun. And it needs to be in a new moon phase for all of this to piece together and for it to work. So there's another type of solar eclipse called an annular eclipse. And we're going to take a look at that next. All right, as we'll see here today, not all solar eclipses are created equally. So about 5 years before the Great American Eclipse, we actually had an annular eclipse that came through Southern Oregon, Northern California. And to understand this, we need to understand a couple astronomy terms. So as objects go around, they revolve around things. This is the same thing for us going around the sun. There are times in the ellipse, the orbit as we go around, where you're slightly closer to the orbited object and you're slightly further away. And so these terms, perigee means that this is the part of the orbit where you're a little bit closer to the object. And so in this example, the moon is just a little bit closer to us. And there is apogee, and this is when the moon is furthest away from us in its orbit. And so an annular eclipse still needs to happen it can only happen in new moon phase. But if an eclipse happens, solar eclipse happens when it is furthest away from us, if this makes sense to you, if this is the sun, okay, and the moon is a little bit further away from us, it's going to not block the sun in its entirety. And this is what we would see where the moon is outlined by the sun. So an annular solar eclipse happens in apogee. It still does block the sun, but you do not get a total solar eclipse. It's still a really cool effect, still something fun to check out, but you do not get the corona. It does not turn completely dark like it does in a solar eclipse. And you can't see the stars like you can, because you can see the stars during the daytime during a full-on solar eclipse. So an annular blocks it out, still gets some pretty cool effects, but it doesn't block everything in its entirety.